So I think you are not from textile background, probably you may have some difficulty. So media for liquid separation and selection of filtration system. So again there is a large number of slides. So if you see the ideal filter as follows. Whenever I talk about the ideal filter, remove all contaminants regardless of size. It could be fine, large, okay, that is the ideal filter. Has no restriction. So that also gives us idea about the ideal filter. Has infinite dust loading capacity or last forever. Okay, that is not practically feasible. Is infinitely small, take no space. Okay, that's why certain times the vertical towers are being also used for filtration, cost nothing. So, so this is the definition of ideal filter, okay, which is not practically feasible. But we can target, so what we can do at most. So choice of filter fabric, if you see thermal chemical condition, because thermal condition could be different, chemical condition is different. It is not that only one material you can use for making the filter media. Different kind of media material can be used for making filter media. Now properties of contaminants including its particle size and concentration. Okay, properties including its size and concentration. That is also plays a vital role. The best separation technique for all types of contaminants are mechanical filtration, adsorption, coalescence, electrostatic effect otherwise. And if you see the same terminology again, it is valid over here. Filtration clarity, efficiency, filtration throughput, low cake moisture content, resistance to blinding, good cake release, resistance to abrasive forces. This is important for filter life. And for equipment consideration, resistance to stretch. Okay, resistance to stretch, because if there is a material get elongated, recovery may not be 100%. Resistance to flex fatigue, resistance to abrasive forces. So this is the equipment consideration. The filter size, hygienic process, the possibility of regeneration of the filter, and finally the cost. So in one slide you can see what are the requirement is there whenever we talk about the filter fabrics. Now in fact, whenever we try to go for any kind of research, we must look at the integrated science for filtration and separation. We will have to start from molecules. Okay, for better filtration research is possible whenever you start from very beginning, and understanding should be clear starting from molecules. Okay, so it chemistry, it molecular, material structure, biology, everything we must understand. For example, why it is important? For example, if you talk about the pathogen, certain pathogens are very soft. Okay, so in filtration, they can pass through the pores. Okay, pathogen size may be larger, but again it can pass through the smaller pores because it can deform. Okay, so the biological aspect is also important. The surface characteristics is also important whenever I talk about that. Particle size, surface modification charges. The charges of the particle also matters a lot. Okay, what is the level of charge? What is the surface characteristics and particle size? That's why in COVID time the people are trying to use sodium chloride for the assessment of filtration performance. Okay, but the virus is work in a different manner. So I have attended one of the conference abroad one point of time. So they are using the bovine serum to characterize the filter media. Bovine serum, though that bovine serum is having equal characteristic, more or less equal characteristic to that of virus. Okay, so certain cases the people are also going for different kinds of testing system so that you can really characterize the material well, because virus testing is absolutely not possible. Certain bacteria testing is also not practically feasible. So whatever the safe bacteria, the people also try to test the material with the safe bacteria. Okay. So material consideration is also very important. Then the particle and fiber technology, fiber knowledge, fiber size, shape, particle velocity, droplets of particle versus fiber interaction. So single fiber theory is important, but as I told that in liquid filtration it is not much applicable. Okay, because the role of fiber assembly is very important, because there could be direct penetration or seepage whenever the liquid viscosity is more. So particle can penetrate through the media based on the size of the pores. And then fiber filter structure. Next is the filter structure, how we are making the medium, that also plays a vital role. Okay, media play a vital role whenever we make the media. Okay, because it is assemble of large number of fibers. So the media role is important. Now this is not also sufficient. If you go to the next one, manufacturing knowledge is also needed. Okay, to design the filter media. Okay, because it may be in a cottage form, in a pleated form. Whenever it is in a pleated form, again if you see, the flow may not be perpendicular to the plane of the fabrics. Flow will be at some angular direction. If you see the flow direction in the case of pleated media. So the how it is being made and what is the flow direction in the cottage, that also plays a vital role. We need to have the process knowledge, process control, system integration. We need to have the product knowledge also, because in the yesterday class it was also discussed about the regulation. Okay, regulation, safety standard, these are also very important along with the product knowledge. Product challenges, sustainability, and finally you will go to the market, value proposition, market size and unmet needs. So if you see, it is a lot of things are involved. So it is not the straight away you go for a experimental research and you come out with something. We will have to look into all the things before we can successfully go for a particular kind of research. Now designing of the filter media, just now I mentioned that filtration specific requirement is there. Specific requirement means efficiency based on the particles. So these are the filtration specific requirement. Application oriented requirement is also very important. Based on the application, the stress imposed to the material will be different. Okay, because different application offered different kind of challenges. And machine oriented requirement, I will see one by one. So if you see the machine oriented properties, rigidity is important, strength is important, resistance to creep or stretch. If the material gets stretched, obviously the tightness between the drum and the material will be poor. If it is not good, then filtration will be affected. Stability at the edges, resistance to abrasion, stability to vibration, dimensions of availability supplier, and ability to a fabricated sealing gasketing function. So in this case, if you see, abrasion is important, stage resistance is important, flex fatigue is important. These three properties are very, very important whenever we talk about the drum filters. Okay, because it will be continually abraded. If you see the knife, we are discharging the cake discharging possible. So knife will go for a continuously abrading the material. Stretch will be there, as there is a continually fabric will be under pressure. Stretch will be there, and flex fatigue, because it is a repeated phenomena. So that's why there could be flex fatigue. Application oriented property, that's whether it is having chemical stability, thermal stability, biological stability, because sometimes that biological material can act as a nucleus. Okay, in food industries it is very, very important. So that can clog the pores. Okay. So dynamic stability, absorbent characteristics, absorption, weightability. So these are the parameters which is important for application oriented property. And different fiber basically have some good feature. Okay, so we can have lot of choices to select the particular kind of fiber. So fiber selection is primarily based on application oriented property. Fiber, choice of fiber, because ultimately you are making the fabric based on the pore characteristics and whatever is required, but the choice of fiber primarily decided by the application oriented property. Okay. Now filtration specific property, if you look at smallest particle retained, okay, retention efficiency, resistance to flow, dart holding capacity, tendency to blind, already I have discussed this parameter. This comes under the filtration specific property. So three major aspects, one is the machine aspect, one is the application aspect, and third is the filtration specific properties. These are the major aspects whenever we are trying to select the media. And along with that, pre-coat also play a vital role. If you see here, this is the pre-coat, okay, and as I discussed in my last class, the pre-coat can help a lot for finer particulate collection, because it can have a coating, okay, before we are going for actual material fed into the system, so it can give you the better filtration. So pre-coating is not possible in all cases, but in the case of press filter press, we can go for this leaf filter, we can go for pre-coating. It is not that in all cases we cannot go for pre-coating. So this is the description about the pre-coating that already defined. So I am just skipping few slides because lot of slides are there, and cost of filter media also matter, because certain cases the cost is low. Suppose that is why a number of cases, if you see, oil filter are also being made out of paper. Although the fabric performance will be better, but sometimes if you see the oil filter, this is made out of paper. Okay, but it is also resin treatment, because cost is one of the again important aspect whenever we are looking at the particular kind of filter. If you see there is a continuous process, also there could be discontinuous process, and some process like belt filter press in discontinuous process are very popular among all this. So this thing already to certain extent I have discussed. If you see the vacuum filter, okay, by means of vacuum also we can filter out the material, because from the picture it is clear. So the drum filter also operate on vacuum filtration. The diagram is shown over here. Okay, suction is active in a particular zone, but after this zone, during the discharging the solid product, the vacuum is not effective in this zone. Okay, as the vacuum is not effective in a particular zone, so discharging will be easier. So this is the rotary drum filter, and this is the application and key advantage of drum filter. So you can go through this because this material will be with you. So in different industries we can have rotary drum filter, and their application has been highlighted. Horizontal bed filter, it is again the drum filter similar to that, but the filter media is in a horizontal. Okay, now the feed concentration, particle size and feed concentration is different. Okay, and this is the horizontal drum filter. About the disc filter, in yesterday video I have shown you about the working of a disc filter. Okay, so I am not going through this. Again, this is the horizontal pan filter. Again, this is in the principle of vacuum filtration. Okay, now this is the leaf filter. We will see that it is also the vacuum filtration. You can see how leaf filter is available in both the form. It is possible in vacuum, also the pressure form. Both the form it is possible. So it can be used in edible oil, beverage industries. So it is basically outside to inside filtration. See, this is going to the outer side, and this is, you are taking out the oil, for example edible oil, by means of suction. So outer surface are being cleaned by vibration. But the leaf filter is also available under pressure mode. Both the form is available. Under pressure mode also the leaf filter is available. Now this is the another category. The first category was by means of vacuum, and pressure filtration is where the sludge content is more. Okay, particle concentration is more. In that case, we can go for filter presses. Filter presses is very common in many industries. Filter press. Pressure leaf filter, as I told you that pressure leaf filter is also possible. Earlier one was the vacuum filter. Tower press filter. So picture I've shown you the video. Candle filter, belt presses, vertical belt presses. So vertically also we are trying to organize. So that space limitation is there. Okay, that is one of the reasons that why you are putting it vertically. So this is a very common, very simple. Here if you see inside the chamber you are having fabric. Okay. Now this is the first process. You are basically feeding the slurry in the chamber. Okay. Putting high pressure to the slurry in the chamber. Now inside the chamber, continuously if you apply the pressure, then what will happen? The water will move out. Water will move out through the fabric and it will be passing through the channel and through filtrate it will come out. So basically we are applying high level of pressure to the slurry. Okay, as we are applying high level of pressure, automatically the filtration will take place because the water will squeeze out. Water will squeeze out and it will flow through the channel and it will come out as the form of filtrate. So this is the first step. Slurry feeding is the first step. Cake forming is the second step. Okay, third step is that cake form. So no more slurry feeding is possible. Even if you apply high pressure, no more slurry feeding is possible. So the next step is that you can separate the plate. If you separate the plate, then obviously the dry cake will fall off. Okay, so this is a back process. If you see the drum filter I talked about, that was a continuous process, but this one is a back process. Okay, so slurry feeding followed by cake, dry cake, and then the dry cake will fall off. Now this is the tower press. This is again a discontinuous process. So picture, the video also I had shown you in my last class. Pressure filtration. This is the vertical belt presses. Dual belt presses. So inside the belt, the material will be squeezed. Okay, I will showing the video also. You can see there are dual belt presses, how it works. Basically you are having this belt and another belt is there. This is the sludge you are moving and it is trapped in between the two belt, and this belt is basically made out of textile material. You see there is a belt at the bottom and outside the top you are having belt, and by means of belt you are squeezing the material because belt basically porous belt. If you are squeezing the material and taking the sludge in between, obviously the water will move out. Okay, so this is candle filter pressure filtration. You can see that how the pressure filtration operates in candle filters. So it can be used in pharmaceuticals. So it is outside to inside filtration. You apply high pressure. So through the candle, the clean water will come out. This is another configuration, perforated basket centrifuge. Centrifugal filtration, in the last class I have shown you the video. You can see the working of the pillar centrifuge also. This is the membrane filters, and different membrane filters is having different capability. Pore size range will be for reverse osmosis, it will be very low, 0.0001 micron. Okay, microfiltration it will be 0.1 to 10 micron. But the task is different for different types of membrane filtration. Okay, use of membrane filtration for water treatment, food industry, pharmaceuticals, industrial applications and other applications. Now the same thing again I am repeating, like selection of filter system, gravity filter. If the sludge content is very high, if the sludge content is less, in that case we can go for gravity filter. Then vacuum filtration. Then gas pressure system, centrifugal and the mechanical pressurization system can deal with the large dirt concentration. Solid concentration is more, in that case mechanical pressurization can work. So the similar slide. Now this properties of the solid is important, properties of the liquid, operating parameters, configuration of filter media, principle of filtration. So that will basically influence the filtration efficiency. You can say lot of parameters can have influence on the filtration efficiency. So understand the liquid and particles, determining the filtration needs, appropriateness of housing, consideration maintenance cost, regularity compliances. Now selection of filtration system, I will not go through this because it will take time, because lot of slides are there. So here it is basically just to select which kind of filter to be chosen for a particular kind of application. Now going to the different kinds of filter, back filter. Okay, back filter will be similar to the net type of filters. Okay, it is not like the bag filter which is used for air filtration application. Air filtration application bag will be different. Here this kind of bag will be different. Net like of construction is there, and many industries, food beverage industry, paint industry, this kind of filter is used. This is the cartridge filter. I had shown you the cartridge filter. This is the pleated cartridge. This is another pleated cartridge. Application will be different. Okay, see the kind of pleating. This is a relatively new design. So pleating will be in a different configuration. This is engine oil filters. You can see, okay, I don't know why it is not working. This is the hydraulic oil filter.
Lights of the Donaldson spin-on liquid filter, which is made for durability and consistent quality. The Donaldson louvered center tube and spiral lock seam allow.
Why that hydraulic filtration is required? For operation of crane it is required. Okay, for heavy vehicle operation of the crane it is required. If the contaminants are removed, then obviously you will get higher wear and tear. One thing I must refer.
The Donaldson product lineup includes quality hydraulic filter assemblies, filter heads, replacement spin-on filters and filter cartridges, test points, and reservoir accessories. Let's look into the hydraulic oil holding tank. It's here that most of the contaminant finds its way into the oil. First, it's important to note that new hydraulic oil is not pure. At an approximate ISO cleanliness level of 2119, it is significantly higher, that is less clean, than OEM standards. This has prompted a leading global heavy equipment manufacturer to recommend filtering new oil before pouring it into the hydraulic tank. Water can also enter the hydraulic system via the holding tank when moist air inside the tank condenses as the outside air cools.
So it is possible in offline mode also.
Products for hydraulic systems of various applications and sizes. Looking at this animated hydraulic circuit, note how the oil is drawn through a strainer in the tank, which removes larger debris. The oil then goes onward into the low-pressure pump-protecting suction filter. Low-pressure filters are the most commonly used type in a hydraulic circuit. Donaldson has a broad product line of low-pressure spin-on, cartridge style, and in-tank filters for solving filtration challenges in virtually any application. From here, the oil, which has been filtered of potentially damaging particulate matter, goes through the inline pump. It is then filtered again in the high-pressure section of the circuit. This second filtration is to protect the expensive hydraulic components, the muscles of the system, from particulate and debris. All of our high-pressure filters contain Donaldson Syntex synthetic filter media, specially developed by Donaldson for high-efficiency liquid filtration. After doing its work, the hydraulic oil proceeds back to the holding tank. It first passes through the medium pressure return line filter, which removes contaminants generated during component activity. Ideal for medium pressure application in the circuit is the Donaldson Duramax series. Duramax is well known as the highest rated spin-on style filter available and is most often used in return line positions. This new Duramax filter allows you to choose between a spin-on or bowl cartridge style filter without changing heads. The new filter interface makes service easier and provides reliable sealing without having to torque to specification. Its improved performance is a necessity in some applications for meeting ever-increasing system cleanliness requirements. Although cellulose media will suit some applications, others may require Syntex synthetic media in medium pressure applications. For the same media area, the Syntec media gives a lower pressure drop than the cellulose media due to thinner fibers.
Okay. Now this is for better working of the crane. Okay. See, one point I must mention that whenever we talk about the fine particulate coarse particle can cause more damage to the crane. It is not that finer particulate matter. Whenever you are breathing, fine particulate matters a lot. Okay, it can go deeper to the alveoli. But whenever you talk about the machine, engine oil, then the coarse particle matters a lot. It is not fine particle, it is the coarse particle that can cause more damage to the material, to the injector engine, okay, in the injector nozzle and also in the hydraulic crane. So these are the different type of cuttage, nominal rated cuttage. Why it is nominal? Because it is absolute not possible. It is yarn is wound onto the package. Okay, high flow filter cuttage, different types of cuttage are there. Okay, coalescing system, these are the coalescer. Yes, here some of the definition I had given. Here if you see if you want to remove the large micron rated cartridge, then lesser pressure drop. If you are going for smaller micron rated cartridge, greater pressure drop. So that also I have explained already. Okay, another aspect is that absolute versus nominal rating. Nominal rated cartridge means 60 to 98% removal of a particular size. That is known as nominally rated. Whenever I say absolute rated, that means it will be 99.99% removal. Absolute rating is possible in the case of woven fabric, as I told, and whereas non-woven fabric can be used for nominal rated cartridge. Okay, and another aspect, if you see, one is that standard versus pleated. Pleated can give you more larger surface area, but the flow direction will be different. Okay, flow direction will be different in the case of pleated one. Another important aspect is the gradient density filter. If you see number of cases, this is the new development that gradually the pore size becomes smaller and smaller. Instead of making a uniform structure of pore size, it is better to have larger pores initially, because that will give you the energetically more favorable condition and greater particulate capture. Fine particle will be captured at certain depth. So the pore size is not uniform throughout the body of the filter media. So this is known as gradient structure, density filter, that also are being used extensively.
Like it would be more of a composite. Within one
Yes.
particular, we cannot have.
Yes, it is a kind of composite. Sometime what the people do.
Blinding, then others will also get affected. Blockage will occur if it appears in the bottommost layer, then the top.
See, this will operate in the depth filtration case only. In surface filtration, we cannot go for gradient density filter. Whenever you are making a cartridge, basic idea here is that energetically it is more favorable, because you are separating the large matter first, then finer to finer material. People also think about why not use the nano layer at the bottom, nano layer. Okay, in the cassette, but if you are using 100% nano layer, one is the cost will go up, but pressure will also very high. So only a nano layer at the bottom, okay, coarse layer on the top. Okay, so the gradient ratio can be of, I mean, this is the use in number of places for better filtration. Now, basic consideration, this also I have highlighted. So, and this temperature, based on the temperature, chemical nature of the fluid, we can choose the right kind of material. Okay, this is the few properties of the fiber. Yes, coming to this whole case, configuration of filter media from textile material. One is the membrane that I have already discussed. So, in a systematic way, I have mentioned it here. Another one is the yarn. Yarn also take as a filter media, because whenever you are making it a cottage, the yarn can also lead to filtration. Woven or knitted fabric, that is another aspect. Non-woven fabric, primarily needle punch, spun bond, spunless are used. Other category like link fabric, duplex, semi-duplex, these are also being used. Now you can see, other than textile, you can have the metallic filter also. So several types of metallic filter you can see, metallic or non-metal, metallic and ceramic filter, paper filter, sintered metal powder or fiber, plastic, metal filter. So this side it is metal screen, okay, metallic filter cartridge, oven filter mesh, wire mesh, porous plastic tubes. So apart from textile also you can use the other material also, non-textile. Sintered metal powder or fiber. So in this case, sintered metal powder, you can, this also is having the filtration capability. How the sintered metal fiber has been made? Any idea? This is the metallic fiber in non-ovens. How it is made? Basically, the powder is dispersed on say polyester. Polyester is melted afterwards. So that whatever is the dispersed powder, they will take up the form of fiber. So first of all, you will have to make the non-woven sheet made out of polyester. You can disperse the powder. Okay, so it will be having some coating on the fiber. After that, you can melt that fiber. If you melt that fiber, it can take up the form of fiber. Okay, so the basic idea here is that it can give you the lower pressure differential.
You also lead to something like the hollow fiber.
No,
Because
no.
once you melt the fiber, then
Melting, see, ultimately if it is used for hot, when the temperature is high, okay, when the temperature is high, we can go for sintered metal fiber or powder. Okay, ceramic is also having very large capability. Instead of ceramic metal, we can go for ceramic when the temperature level is suppose more than 1000 degrees centigrade.
Emulsion spinning system. That is spinning system.
So certain cases catalytic recovery, then we can may have to go for very high temperature filtration.
Whether the fiber form will be in hollow form because the
No, fiber will come out. It is so fiber will come out in a polymer form, but it will be a kind of porous type of structure. It will take up some form of the fiber because of this sintered metal. But advantage over this is that it will give you the better capability for the fluid flow. Okay, powder form the fluid flow resistance will be more. In fiber form the fluid flow resistance will be less.
in case of the sintering of metal, we are using polymer as well as a metal.
No, polymer, only powder. We are not using any polymer here. Here in this case we are using polymer. In this case it is 100% powder. Yeah.
In case of the sinter metal fibers, we are using a one polymer, another is the powder.
Yes.
From that we are manufacturing the fiber.
Yes.
This kind of a emulsion spinning system. I think. In case of the
Maybe
ceramic, they are
I don't know
using emulsion
exactly, but this is the how it is being made. If you see, this is the other type of various configuration membrane filters that I have discussed, and we can also have the symmetric membrane, asymmetric membrane. Okay, symmetric membrane will be simple, but asymmetric will be high performance membrane. And nowadays, basically, people are going for asymmetric membrane. Let us look at the asymmetric membrane. One of the asymmetric membrane which is used in RO, polyamide layer 0.2 micron, polysulfone layer, the pore size could be 0.0001 micron. This is the pore size in polysulfone layer, and polyester base is only for support. Basically, you are having three material into one system. three material into one system. It is an integrated material, three material in one system, and this is very much porous. Polyester base is very much porous. Okay, here polysulfone layer pore size will be 0.0001 micron, and the polyamide layer is the upper layer, which is having 0.2 micron. So this is basically asymmetric membrane. Okay, because earlier time the people trying to use the symmetric membrane. So only you are having one polymer. Now we are going for multiple type of polymers.
Gradient density.
Yes, kind of gradient density. Okay, but that can give you better performance. Asymmetric can give you the better performance as compared to the normal one. So this already I have discussed. Okay, one thing I like to mention that basically I will also cover the testing part to certain extent. Testing, characterization and evaluation. What do you understand by evaluation? Any idea? What do you mean by testing? Testing means we can simply test the material. Characterization means we are characterizing the material based on the test result. So it will be high performing material or whatever. Whenever we perform test characterization or testing, it is done in a small setup. Like yesterday you had shown in a very small setup to show that how the material can be characterized. How the material can be tested, testing, and followed by we can say that this material flow behavior will be better as compared to the other material. But what is evaluation? Any idea? Because people are using it loosely without having any idea. They are using this, sometimes they use evaluation, sometimes they use characterization without proper understanding. What do you mean by evaluation?
Assessing the
Assessing the
Actual assessing the real performance of the material, field performance, and that is one of the most difficult tasks. Translate lab data into application level performance and decision making. That is basically evaluation. So field test, I mean the testing in the lab can give you the different kind of result, but whenever you are going for application, if you see the flow dynamics, it is very different. In different machine, the flow dynamics is very different. Application, how it will perform, that is a big challenge, because lab scale also seen that okay, its life will be less or higher. That is in lab scale I am saying. Suppose in lab scale we can say that it is maybe having 2 times longer life than this, but in application wise what will happen? That is the one of the most challenging tasks. Again, in Bloom taxonomy used to say creativity, evaluation, it comes at the top level. But in this context, evaluation means we must be able to assess the material performance we will use. For example, if you are going for abrasion, abrasion is basically an accelerated testing. Whenever we do the performance testing in the lab, it is basically can characterize the material. From that, can I say that material is having double abrasion resistance? In real life, that will give you the double durability than that other material. That is the main challenge. Evaluation is the main challenge. Okay. For example, the yarn strength is less. Can I say that it will perform inferior in the while it is in the machine? We cannot say like this. We cannot say straight away. So there are a lot of aspects. There are a lot of aspects before we are going for evaluation, and there that is the thing is lacking in most of the research. In the most of the research is restricted to testing and characterization. It is not translated to the industrial practices. Why it is not translated? Because we are lacking in the evaluation part. In future, what I say that we can have AI technology, and if you feed the many data in AI system, how the material performs, that could help us a lot for the evaluation of the material. We can feed the raw data, and we can also see what actual performance data in the industry, and from that we can get a lot of information. In fact, because in multiple forum I have also addressed this issue, evaluation issue, although it is not understood properly, I mean about the evaluation of the material. Now this is the practical requirement. I will try to finish it off within 10-15 minutes. I try to. So pore size, rating, efficiency, and all these are important. So this already I have defined, number based and mass based. We will look at it, the practical implication of this. Whenever I say that total suspended particle in sludge minus total suspended in sample, it is in the form of gram. Okay, weight. Okay, and beta, if you see, it is in terms of number. So here in this term of mass, and other places it is terms of in number. Which one is important and why? It is not the why is very important for any academic research. Why it is so? Should I use number? Should I use the mass? So you have to see the application. Because in the beginning also I was discussing about the cleaning of wafer in semiconductor industry. So the water should be 100% pure, because the particle in the water that could be bigger of 5 micron, 5 nanoscale, because 5 nanoscale could be the feature of a semiconductor. So it could be bigger than that size. So the point here is that here it is emphasizing on quantity of the particles, not on the mass. So mass is one hand and particles is one hand. So suppose from this picture it will be clear, although I have discussed this issue in my earlier class. Suppose in downstream you are having one particle. Upstream is same in both the cases. Filter media, upstream is same. So here I am talking about 1-2 micron particle. In this side you are having 1 million of 0.02 micron particle. So suppose if you see mass of 2 micron particle divided by mass of 0.02 micron particle, what will be the ratio? 1 million. Okay, because this will be the volume. From volume you can take the density into account. You will be able to find out, because density will be the same for both the cases. So density will get cancelled out. Okay, so if you take the volume, if you take the volume, and from the volume you can derive the mass. In both the cases, what will be the mass basis efficiency? Anyone? What is the efficiency? Whether there will be any difference in efficiency on the basis of mass? Again I am repeating, here you are having one particle of 2 micron. Here in this case mass of 1 million particle is there, which are of 0.02 micron. Mass of 1 million, particle of 0.02 micron. Whether the efficiency will remain same or different? Yes, mass base it will be the same, because 1 million of 0.02 micron mass are same to that of this. But in practical life, then in number of application, number plays a vital role. If you see the air filtration application, nano particle can give us more damaging to the human health as compared to only 2 micron particle, because it will be immediately arrested by in the tract, in the respiratory tract, it will be immediately arrested. But fine particle can go deeper into the alveoli and it can cause more damage. Similar is applicable to the liquid also. So application wise we will have to see whether to be used number or whether to be used mass. Okay, because there could be great impact of this very small particle in real life.
So for the mass applications, which one is the appropriate number? Right?
See, if you are going for sludge, removal of sludge, high concentration, you cannot count the number. Sometimes what the people do, they only count the number on downstream side. That's all. Only downstream side. But they cannot compare or find out the efficiency. Only mass base they are trying to find out. And number also they count. So that was there in the people also in some of the developed countries, they are also started thinking, why PM 2.5? You know the PM 2.5 indicator is all based on the mass. That is the unfortunate part. But with the same mass, if you are having 0.001 micron particle, that will be very much damaging for human health. Mass may be the same, but that could be more damaging. So therefore some countries have taken initiative. I don't know whether it is in the part of the process or not, but at least not in India, but in many countries people have thought of this aspect. So this aspect is very important aspect. Cake discharge, mass of cake discharge, total mass of the cake form. This is the cake property. This can be done in the lab scale research. Moisture content, dewatering efficiency. If anyone is doing the lab based research, they can find out in a small setup, they can find out dewatering efficiency, moisture content, okay, blinding tendency, weight of fabric after filtration. This is temporary blinding, initial weight of the fabric. And permanent blinding means what? After washing cycle, you can see weight of the fabric and initial weight of the fabric. Then that can give you the permanent blinding, because after washing whatever remained, that means that is a permanent blinding state. So you can find out the permanent blinding also. So it could be based on the weight it could be based on the solid. You can have similar equation for solid as well as this one. Now coming to that, if you see the different yarns are being used, staple yarn can give you the maximum clarity because it is having hair inside it and it is porous structure, and multifilament can give you the monofilament can give you the least clarity. Maximum throughput is possible monofilament, least throughput is possible in staple. Okay, low K moisture content is possible in monofilament. So what is in the slide, some of the properties is good for certain thing, okay, certain filament or yarn, certain properties are good for other cases. That's why I discussed about this material. Face side is multifilament and back side is made out of spun. Because if the face side is made out of multifilament, okay, you will get the advantage of easy cake release, okay, but back side is made out of your spun yarn staple fiber, you will get the better abrasion resistance. So you will get the both the advantage by having this kind of structure, okay. So I am just skipping it, okay, different combination is there. Now you can have strategic research. I am not going through this because you can have some strategic research so that optimization is possible. These are the other kinds of material: double layer weave, satin weave. Satin weave, as I told, that it would be better to dispose of the cake. The surface will be smooth. So you can also have the metal fiber fabrics. You can see that different metal fiber. Okay, duplex, semi-duplex kind of material, link fabric. Link fabric is already I have shown you, and this is the comparison where the link fabric can be used duplex and semi-duplex. But obviously, whenever the contaminant size is large, in that case only we can employ the link fabric, duplex fabric, semi-duplex fabric. But if you see the link among them, the link fabric is more strong. Okay, reusable. Okay, so depending on their plus point, we can use the different negative point. We'll have to consider that. Now, non-woven fabrics. This is the classification of non-woven. Three majorly non-wovens are being used. Needle punch, because many of you are not from the background of textile, you may not get the things properly. But gradient density media can be made in the non-woven fabric also. Okay, if you see one layer is made out of different fiber, another layer is made out of different fiber. You can make the finer fiber layer at the top, you can have the coarser fiber at the bottom, but it could be otherwise also. For depth filtration, finer fiber layer should be at the bottom, coarse layer should be at the top. Okay, now nanofiber uses, what is the basic concept why the nanofiber gives us the larger filtration capability? Anyone? Larger surface area. That is the primary reason that why that, because there could be better interaction between the particles and the fiber. If you see, compare the surface area, it could be large many more times as compared to the normal fiber. So it is not the pore size and something else. Okay. Usually what happens, if you consolidate the material, you can get greater larger surface area. Okay. Compact pore size is also reduced, but pore size is basically have the resultant, but one should not connect the pore size directly to the efficiency. As I told already that for if the contaminant level is very low, in that case only you can connect the pore size to the fabric, to the filtration capability. Now this is the finishing treatment that can also improve the filtration capability. Now future development, if you say that all the time we are going for filtration efficiency, flow resistance, filter life, storage. So this I have written in a one place, okay, because the research are continuously going for improving these aspects. Now if you see, this is the some of the advanced area of research, nanomaterial research, bio-inspired filtration. For example, if you are going to develop the filter material similar to the lotus leaf, okay, so hydrophobic material, hydrophobic oil can pass through it, but oil cannot, but air, the water cannot move through. If you see the lotus leaf, because of the air, entrapped into the pillar, nano pillar, the water roll out. So if you are having oil and water mixture, oil will be able to pass through, but water cannot pass through. If you see the plant, root of the plant also takes up the water, but it doesn't take up the toxic matter. So many things is basically inspired by the what is happening in a biological field, mimicking natural system. Okay, we can also have the smart filter, smart system, which can regulate the pore size. Okay, energy sector, medical sector, and these are the emerging area like microplastic, because microplastic, if you burn the plastic, there is a problem because dioxin is generated that is harmful for human, because cancer, it can lead to cancer. If it is in the water, that also lead to a problem. So both cases it is having a great risk to the human. Okay, that's why many countries it is banned. You cannot throw the plastic here and there. Okay, many in the India also many places it is banned. In Kerala, if you go, you see the plastic is banned. Okay, in Manipur and some of the northeast area, Himachal also, it is not being used because this it can have lot of impact on human. So removal of microplastic is also important. Okay. Now here I have defined one term. If you see forward osmosis. Now you all understand osmosis. Let us look at what is osmosis, by the way. I don't know why it is not working. Can it work? No, I don't know why it is not active. Huh?
Maybe that is not in the directory.
No. Okay, what do you mean by reverse osmosis? Any idea? Why it is called reverse?
Passing of material from higher concentration to lower concentration through the semi-permeable material.
Now suppose in one side you are having water only, another side you are having contaminant water. So basically from which side to which side the water will flow?
Low to higher concentration.
Lower side means what side is lower? Pure water is lower concentration. Lower concentration to higher concentration. So if you apply pressure, then what will happen? Reverse. Now forward osmosis means what? You are deliberately in the pure water, in place of pure water, you are keeping a water which is having higher solute. Okay, so normal process you will have to apply high pressure, you don't have to apply pressure over here. Normal process it can be performed.
Simplest example is kismis. Kismis.
Huh.
Whenever we are putting in the water, the swelling of kismis, that is the reverse osmosis. Kismis membrane is the example of reverse osmosis.
So some of the recent development, DRDO developed multi-layer nanoporous polymeric membrane for high pressure seawater desalination. So these are the some of the information I am providing. For removal of microplastic also, sponge made out of cotton and chitin can remove 99.9% microplastics. Okay, nano composite membrane are also developed. Thin film composites are also being developed. Forward osmosis process. So disposable recyclability are also becoming important. Sustainability is very much important with the time. Green impact in production, minimal environmental impact, and energy saving. This is all from my side. So we have taken 10-15 minutes more. Okay. So any question? Because you can get lot of idea from the slide that will be shared. Also one of the book will be shared with you. I don't know whether it was shared already or not. Whether it was shared? So probably by today it will be shared. Okay. So you can go through this, then you can have idea.
Industrial RO, there is backwashing and how things are doing their performing.
Industrial?
In industrial RO system, backwashing or cleaning is doing regularly, as you already shown in the.
No, industrial wastewater, actually as I told that it is a multiple stage process. Initially, by coagulation and your flocculation technique, you can remove that all sort of heavier particles, large particles. Then at the you can also go through the filter press to remove that cakes. Okay. Then finally you have to go for this. So suppose if it is used for the drinking purpose or whatever will be the purpose, based on that you will have to select the stage. Okay, otherwise I have seen a number of places the people are going for filter press, okay, to consolidate the cake, and cake is disposed of, okay, in landfill area. So it is basically you will have to one has to go for multiple steps of process. It is not a single step.
So my question is regarding your RO
Backwashing.
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 Of RO.
Huh.
That is usually performed in industry.
I think they usually perform. I don't know. I don't have the idea. Probably they should perform, because if you want to get a longer life, okay, obviously you will have to go for backwashing.
I have visited and tried in industry. Actually, they are using RO and they are using clean water for the white towel dyeing process. Actually, in that case, they are changing the cartridge. They are not using
Usual
backwashing,
industries
especially in the
understand
RO
that
unit.
only. People use reusable use and throw cartridge
Yes, use and
filters
throw
because
cartridge.
it's
Yes.
cost
Plastic,
effective.
yeah. The other one is more costly. Yeah, yeah, costly.
No,
No, no, backwashing they are not using. I have not used. In RO, they are not using backwashing.
so we have taken a 5 minute of break. So if you need to
CPP plant, they are not
go
using
and
RO.
washroom or drink some
Yes.
water, you just